Hello, welcome to this tutorial. I'm Morris Dimba, and today I'm going to show you how to create or model a parametric concrete bridge deck in Tekla structures, and we'll get started right away. If you take a look on the screen, you can see a very small, a minimized screen of Tekla structures. Reason why we are going to use around three cropped screens that will interpolate between the two. Now I'll go ahead and open the bridge deck already drawn in Rhino. So let me just open it so that we have a look and explain every bit of it as we go forward. Now this is what we have. Let me just maximize it for the time being. Now I have this in Rhino. You can do this in AutoCAD and import it into Rhino, or you can do it straight in Rhino once you have the exact dimensions, or if you have the coordinates. If you have the coordinates, you can feed or import the coordinates straight into Grasshopper, and you will be able to generate the profile of this deck following this path or the path that coordinates define. So in this case, if you don't have the coordinates in place and you have the exact dimensions of your deck as it is here, you can create your own deck and extrude to the specific dimensions, then array it along this path. That's the second option. The first option I've showed you, I've indicated that if you have the coordinates, you just the coordinates will define the profile of the deck, so you don't need to do all this. Or maybe what you can do, you can just do these grooves, and about these grooves I'll explain right away. Now let me just turn this by pressing Ctrl Shift here and pressing my left button on the mouse. This is to rotate in Rhino. Now let me switch back to a different view. Now this is the front view of this deck, and these are the slots and the grooves that will enable this deck interlock when it comes to the time of installation on top of the piers or the bents. Now what I did, I just created these rectangles, and I did an offset of this. I did an offset of these inner rectangles. Just did an offset. Same to these also. All these are just offsets of the main rectangle, as you can see here. Now let me switch back to the other view, and this is the view, and you can see the side view of this. You can see I made an offset of those rectangles by 50 millimeter. We can confirm that dimensions. I think we can do that. Let me just try and check the dimensions, if you can make that dimension maybe from that to that. That should be 50 millimeter. That should be 50 millimeter, and now that should be 50 millimeter because I did that. Now let's change another view to, now we go back to our perspective view here, and let me just turn this, and what I'm talking about is this. Let me just zoom it close, and press Ctrl Shift and turn. So what I'm talking about, I made these rectangles and made an offset of negative 50, and I gave an offset away from the main by 50 millimeter. So once you've done all this, and you've done everything here, it is a very simple thing. I'll upload a very extensive clip or tutorial that will pick this from the scratch, but for the time being I'm just giving you an overview on how this can be done, and how you can interpolate it with other softwares. Now let me just bring this close like that. So on this side we have the male I mean the male grooves that will interlock with this end. You can see I've made an offset of these rectangle inward, just to create a groove that will enable it interlock properly. So what I'll do here, once I've done this, I'll just extrude to create a male groove, and this one also I'll create a groove inward and cut this part to create a slot where these will interlock when it comes to installation. And that's all about that. And now we'll switch straight to Grasshopper, and I'll minimize this and minimize this screen, and maybe I'll drag this to the bottom end right there and make this slightly big by putting that. Now let me bring this close. Now I want to go to I want to interpolate this drawing or this model with Tekla structure, and that plugin that will make us work in between the two software is just this plugin called the Grasshopper here. This is what will help us in making or creating or modeling a parametric concrete bridge deck that I'm talking about. Now I'll just go ahead here and type Grasshopper, and it has been predicted right there, and we'll just press enter, and the Grasshopper will load immediately, and we'll give it some time to load everything. And here it is. Now I'll go ahead and close this and follow my file where I saved it, and I saved that on my desktop here. Let me just scroll down and pick it right here. This is the folder, and here we are, and give it some time to load everything so that I explain, or you see exactly what I was talking about. And this is what I did. Now this is how it looks. Let me just turn that around and zoom it close. So what I did, what I was explaining prior to making this look like this, is the offsets that I made and extruded to create a male groove here, and also to create the female grooves here. You can see that in this case you cannot see whether it is grooved, it is engraved or not. You'll see that once we've taken this into Tekla structure. And the parametric part that I was talking about is this. Let me just bring this close so that you see what I'm talking about. Let me just zoom it by pressing Control, then press the left button and move your mouse. This will bring it close. This is parametric in this case. That this is the full width of our concrete bridge deck. From this end to this end is 28. 2.88 meters. So we can play around with the size of this by maybe dragging this to that position and dragging that to that position, and these adjustments or these limits can be set right away here by clicking on this slide. This slide you can get it from this end, and that's how you can edit it. Now I want to just set fresh limits for this, and I'll click on that and click edit, and come straight to integer numbers. Now integer numbers, here we are trying to avoid anything to do with decimal. We'll want to work with integers. Now once you've clicked on this, first of all go to numeric domain, click on minimum, double click on the minimum and feed in the minimum dimension of your preference. Now in this case we'll change it to 100 and click OK. Now if we come here and drag this and drag it to that, you'll see it will go all the way to 100, and it will change to 100, and it oscillates between the 100 and the full width of our deck, which is 2.88 meters. And that's it. Now if I get rid of this, you'll also see everything how it looks. If I delete all those, and you can see how this looks. This is how it looks in this case. Perfect. Let me bring it close, and these are the grooves that I was talking about, that once you've created your triangle here, your rectangle here, you do an offset. Then once you've done an offset, then offset it away from the main rectangle by a specific dimension. I did a 50 millimeter away from the main. So that is what I did here. And all these you can see is the male groove 1, male groove 2, male groove 3, male groove 4. If I can go individual, I can go in step by step and click on them, and you can see what I'm talking about. Male groove 3 is that, male groove 4 is that, and also I can shift the other end and click on the female groove, and you can see the other end, the female groove that is turning green right there, and the female groove 2, you can see that, and that's as simple as that. Now I'll bring it back. I'll undo whatever I did, and everything will be back where it was. And once you've done this like that, you shouldn't worry about the explanation. I'll do another clip that will explain, that will take you through from the scratch. Today I'm just trying to limit my time, because it actually takes a bit of your time. It will take a bit of your time from starting it from scratch. Now I have a path here that I want this deck to follow along this. Now how do we do that? What we'll do here in this case, I have my road line here, which is this case. It was assigned like this by picking set one curve, then pick on that, then right click to enter. Now I want to populate this along this path. Now what I'll do, I just double click here, and I'll look for an array command, right there, and I'll pick curved array right there and bring it to that position. Now the geometry here is this geometry of the concrete bridge deck, and this is the geometry that I'll pull along and connect to the geometry here. Then the road line I'll connect to the curve here. Then how many of these do you want to follow the profile of this curve? And that now will be determined by this. I just pull up this and bring down here, and create one here as I did. Like I need maybe 10. Just double click here and need maybe 10, and the maximum of maybe 200, and that's how you do it. And this is how it looks. So now I've already done that, so I have my limit that goes to 20 and 100. Now I'll get rid of this because I've just showed you how to do that. Now this is the counts that will drag and connect here. Now how do we know the geometry that combines everything that we have here? First of all, bring it close. And if I click on this, you'll be able to see some selection. Some components have been selected. If I click on this, you can see almost the whole deck has been selected. So what do? We pick on this, then drag this and connect to this geometry here. Connect to that geometry that has been connected. And let me just drag this aside so that you can have a preview of what's happening on my left side, that is inside Rhino. prior to taking it into Tekla structures. Now, I've pulled this geometry to connect. I pulled this geometry to connect up with this array button here. Now, I wanted to follow this profile of this curve. Now I'll pull down, I'll pull it and instruct it to follow this curve, and give it time, and you'll be able to see it has followed that curve like that. And if I bring it close, you'll see some components have been left out, which is not a good idea. And this engrave, the part that that was engraved to as a female part, that will make ease of interlocking with the male parts, have been attached together with the deck. Now, what we are missing here is just a very simple part. Let me just click on the screen first, or disable that selection, then press Ctrl Shift and turn this round, because if it is active in Grasshopper, it makes it difficult for you to try to maneuver around a model. Now, you can see this. You can see this. The grooves are in place, but we are missing some components, so we want to put them in place prior to now taking everything to Tekla structures. Now what do? We take a look on the component that we need to pull up and link up with the path and be part of our deck. Now I'll drag this aside and bring another array command here. I'll bring another an array command here, right there. And I need several of these because I'm going to use a number of them. So I'll press Ctrl V and get some copies, and press Ctrl V again, Ctrl C and Ctrl V, and get some 2 copies here. Now, I want to copy this. I want to take these components here. Let me just select on that. I want to take these components to attach themselves or follow this path. What do I do? I pick on that, then link it up. I link this geometry. I link this geometry to that. Then define the path to be followed, and I'll pull the road line as the path and link it right there. So if I bring this close, you can see one is there. You can see they're there, but we've not given instructions of how many. So this is just a default number of copies that have been projected along this path. Now, prior to introducing the number of components, we'll first of all define the components that will follow the path to be part of the concrete deck component that will be parametric. So we'll try to show how parametric it is in both Tekla structures and in Rhino. Now we'll mouse over these to check which part we've left out and which part we haven't defined or directed to follow that path, and do so. If I zoom close, you can see the male grooves are not yet there. So where are they? They're here. So if I click on that, you can see if I click on this, you can see the upper part, and if I bring this close, you can see the other part, but these ones are already in place. So these ones haven't been connected with our concrete bridge deck. Now what we'll do, we'll just drag this, click on this or any of this, and drag close. I made several copies because I knew that we'll need several of these. Now I'll click on this, then link this geometry to that, and also come here. We need this side of male grooves that will interlock when connect to the other side with the other to define the path that we intend to follow as defined by the bridge. Now we have this in place. Now we'll go here and drag this and bring this one here and pull it and link that geometry, link it with that geometry there. Let me drag it up slightly. Now if I click on this, you can see the right side of the male groove also is selected. Now what we do, it's quite simple, and this is what we are going to do. We'll just click on this, drag it and bring it here and select on it and connect this to that. Now I've not yet introduced the path to be followed and the counts of the components to be copied along the path that has been defined or is defined by the bridge. Now we have the bottom end here, these grooves here, the bottom end that interlocks with the male groove, with the female groove on the other end. So we'll pull another one, press Ctrl V. So we have this here. So we just need one in this case. We just need one in this on this side and connect that to that. Then I'll come this end, and that one is already in place. It's combined with the main components as the bridge deck. Now I'll pull this. I'll connect the output of the bridge path and connect it with this, and also I'll drag this. I'll just bring it close so that I don't move so far to get it, and connect that to that, and come here and connect that to that. Bring it close, and also I'll bring it close and drag it, drag that and connect, define the curve to be followed right there. So how many counts do we have? So it seems we have everything in place. If I zoom close, you can see this already in place. If I click on empty screen here to deselect everything there and try to turn this round, you can see that we have this in place. Or just let me just drag this, and you can see the grooves are in place. Perfect. And if I zoom the far end here also, you can see that's all, and we are not yet complete. Now the next move is now we've left another part. We've left the right hand side of the male groove. Now we'll connect it. We'll connect this. Let me just drag this close. We'll define that path and connect it with that, and you'll be able to see the grooves in place. Perfect. Now we have this in place. We have this and we have this. Now it is the time now to interpolate with the Tekla structures, but prior to that we want to define how many components we need to be arrayed along this path. Now what we'll do, we'll come here. We'll first of all take this road line to that spot so that some sort of uniformity is shown. Now we need a number of these, so I'll drag that to that spot, maybe 20 right there, 25 or so. And now we want to define, we want to connect the counts to that, and you'll be able to see how that is populated right there. And also we'll connect this count with that, and also we'll come all the way here and connect this to that, and connect that to that. Perfect. And we'll connect this to this. And we'll go ahead and connect the rest. Let me just drag this and bring it close so that we don't move too far to pick it. So we have all that in place. Now we'll just drag that and take it to where it should be, and bring this close so that we can read whatever is on the screen. So if I make this bigger, you can see how it looks. It looks maybe like something like a wiring system, but it's not. This is just some sort of using a Python maybe to come up with a model. Let me just minimize that and drag that aside. Now we want to interpolate this to Tekla structures. Now you can see this. So if I drag this, you can see it will respond, and it takes time to respond because of the number of geometries in place. So it demands so much from the system, and you can see it is small. It has gone all the way to 460 millimeter. Then we can pull it back to its original width, which is 2.88 millimeter. Now we want to take everything to Tekla structures so that we can do more about this. So what I'll do, I'll first of all make this big, make this a little bit bigger. So to connect this, you can take a look on my menu bar. I have variety of what I can do. I can link up with Revit by using all this. I can also interpolate with Revit straight. I can take this model straight to Revit, and also have all this. We can create a stadium here, a very simple one. Now in this case, we don't want to do much. I'll go straight to Tekla structures, and I'll pull down Tekla structures because I want to connect it with I want to interpolate what I've done with Tekla structures. Now I'll pick on this, then press Ctrl, copy, and I need several of these. I'll just drag that down and remain with 2 here because I'll only need 2 in this case, in this particular part, and also I'll need 2 here. It's a bit if you're new to it, it might confuse you, but it's a very simple thing to do. Let me just drag that and take it there, and press Ctrl or Shift, and drag that aside to give a space for this. Press Shift and drag that to that spot. So we have that one in that position. Now we need another one in this position. Now what do? Just drag that and bring it here. Bring it right there because we'll connect this to that, and also we'll need another one at the bottom end here. So what I'll do, I'll just press Ctrl V, and I'll have another one at the bottom end here. Now I don't think if any is missing. So this is the command that will help us interpolate with Tekla structures so that we can take this to Tekla structures. Now let me just minimize this so that we start connecting, and you will be able to see whatever is happening on the other screen of Tekla structures. Now I'll zoom out and pick on this geometry and connect it with that, and pick on this and connect it with this. You're not seeing anything because I've not maximized this. So you can see this is already in Tekla structures, and the grooves are not yet there because I've not taken them or connected them with Tekla structures. Now what I'll do, let me just come to view here and pick navigate and turn that round, and you can see we have the grooves on this end. We have our holes well placed at the end there, and if I turn around here, you can see this. And now we'll go ahead and do the same thing here and connect here. Click on that and connect with that. You take it to Tekla structures and pick on these and link up with the Tekla structures. And also we will come here and pick on that and link up with Tekla structure right there. We'll just give it some time to process that information, then connect this and connect with that. Perfect. Now the next thing remaining is maybe to to just walk around and check which one we've left out, and that should not be a very difficult thing to do. Now on my left side it is Rhino. That on my left side is Rhino, on my right side it's Tekla structures, and the software that makes us work in between the two is Grasshopper, and the Grasshopper is found in Rhino, and this Rhino can make you work in either Revit and work in Tekla structures. The work has been made simple as that. Now once it is inside Tekla structures, you can now go ahead and start placing your rebars in this particular deck. Now in this case I want just to show you that maybe I want just to show whether this can respond, the parametric response can respond the same as it was showing in Rhino. It can do the same thing in Tekla structures. Now let me just minimize that and come here and play around with my slider that have limits of the minimum and the maximum reduction of the width of my deck. Now that was set here. So if I drag this and maybe take it to that position, and it will take a little bit of time to respond because of the amount of the graphic, or the amount of the resources will be demanded from the system. So you can see it has responded. It has changed to a very thin one of this 674 millimeter. So that's how it looks. Now I can drag it and take it back to its original size or width, and there it is. And also I'll try to increase the number of components of these, instead of this number. So I'll try to increase the number this side. So instead of 25, I'll need slightly, maybe 30 or 40, and then we'll see how that apply to both Rhino and Tekla structures. So we are drawing in Tekla structure live through Grasshopper. So component exemptions, just go ahead and click OK. Just go ahead and click OK. Just go ahead and click OK. Don't worry so much, and click OK. And that's it. So we'll just give it some time to respond and put everything in place in appropriate manner. So if you take a look at the screen here, we have the factor unit, factor unit Y. This is the axis that defines the directions of extrusion. So that should not confuse you with so much mathematics, though we have maths here in Rhino, and that these will be tackled bit by bit as you continue following the channel as we move on. Now I'll come to a Tekla structure and drag it slightly and maximize this so that we can see everything in place, and try now to fit everything into the position. And this is what we have. You can see some parts have been left out, and it has not been left out. It's still responding to the command that was sent to it from Grasshopper. So we'll just give it some time to respond and put those components into use. So we'll just minimize that and just drag it to that side, and still give it some time to read everything and put everything in place, and to make it look like the way it is here in Rhino, because in Rhino here you've not seen anything left out. So the response time is somehow too long when it comes to the message amount of the information sent to Tekla structures from Grasshopper. So you can see it's still responding. So I can drag that and try also to force it to work properly by maybe coming here and click redraw, and see, you can see that everything is juggled up, and you can see some parts have been corrected, and try also to redraw that and see how it responds. We just give it some time and everything will be placed in the right position. Just redraw, and you can see this already in place. So if I come to navigate here, and rotate this, you can see actually what we have. We have the grooves in place. Some have not responded because of the amount information sent is just too much for it. And what we'll do, we'll just try and minimize this and come back to Grasshopper and click on Grasshopper, and maybe try and minimize the amount of the information to be sent the other end. So it will require some bit of time to yield to that information that has been sent to it from Grasshopper. So you see in Rhino it has responded very fast. So these differ with every computer's capacity. You might have a very speedy computer, you might have a very slow computer. So the slower the computer, the more slow it responds to information given to it, because this demands so much from the computer or the PC or the laptop capacity. So it may drag you for some time. So what is key here is just patience. You just give it time to process everything, and everything will be in the right place. So I'm trying to reduce the number here, so that we have everything as it was before. And just give it some time. I want to reduce this number to maybe 20 or 30 there. So once you've seen these two arrows, one pointing this end, one pointing this end on your cursor, means you can either move that side, you can either move this side. Now I want to move this side. Maybe I'll place it right there. So I'll go ahead and close that, and give that an OK here to terminate that. I'll terminate that. It takes a little bit of time to make it respond. Change that, click on that, change that. So I'll drag that also to that spot. Give it an OK right there. Give it an OK. Give it an OK. Just give it some time to respond. So if you come back here, and try now to refresh everything and make everything load properly. Right click once again and redraw, or click on this and make everything fit. This is how it looks, but everything has not been copied properly, or everything has not been transferred properly. So we'll just give it some time and come back this end and try to reduce this number to maybe 50 to 30 or 50, or we'll just change it right away. So I'll come here. Let me just change this because we don't want to take so much time in doing this. So I'll right click here and come to edit. I'll come to edit. I'll edit the number required. So we have the maximum of 100, so we can reduce this maybe to 20. So it's taking a bit of time, but reducing it will not make any change. The reason why it's a bit slow because we raise the number so high so that it takes time to communicate between the two. So the results will be applied, will be taken to Tekla structures after some few moments. Just give it some time. Just give it some time, and we can leave it at 38 right there. Now if I switch back to Tekla structures and try and make it slightly bigger, and this is what we'll have, and I'll come here and redraw and see whether everything will be placed in the exact positions. You can see some parts have been left out. It's still communicating. Now let me just refresh everything, fit everything. Redraw everything here, refresh everything, get rearranged, redraw. So this is how it's done. So you see it's juggled up because the communication is very slow depending on the speed of your system or laptop or the computer. So this is how it is. You can see it's still responding. Just redraw to make everything in place and just give it some time to process all the information. Just redraw, click on that, so it is as everything is getting into place. You can have a look on what has been done, and this is how it looks. So this groove is attached to this groove, to this component, and this will mesh straight with this one, and you will have your decks in place, properly connected. Now I'll just fit in and maybe click on this redraw, and maybe switch back to Rhino, because I want now to go to Tekla structures once everything has been copied properly, or and try also. We can minimize this. I want to show this thing the best way possible. 14. So you see here it is responding properly, and because I'm putting so much pressure on the system, on my system, that's why the communication is slightly lower when means sending the information to Tekla structures. So we'll just give it some time and process the information. Time on this end, it has responded. We can turn that around and take a look. Just drag that aside. This has responded, this end. Perfect. So it's just interpolating it, or taking this into Tekla structures, that the communication is slightly slow, and this is how it's done. So Thanks a lot for watching this video, and let's meet on the next presentation as we wait, or I wait this to respond. And let me just maximize this and try and now deal with this separately in Tekla structures. Let me just try and redraw this. So this one is on the other end. There's some left on the other end. Quite a number. But all in all, this is how it's done, and this is how it looks. And I'll continue redrawing this so that we get everything in place. Fit that. So this is how it looks. Let me just turn that round and you can see that. Now, thanks a lot for watching the video, and let's meet on the next presentation, and bye bye.